For a couple of days, we were focusing on MPLS and we have done a basic lab on MPLS. Multi-protocol label switching uses label to decide the forwarding plane, to decide the data plane. It uses the label control plane to decide the forwarding plane, to decide the data plane. Only the ingress router and egress router going to focus on the IP destination of the packet. So it's label switching. Now, is that the maximum an MPLS can do? No, much more it can do. But it has to couple with BGP. None of us are new to BGP. We know BGP already. BGP is a multi-protocol, meaning BGP has got a lot of extensions. One of the extensions that BGP can have is carrying the label. The BGP protocol can carry the labels in its attribute. So we are going to combine this MPLS with BGP in order to have layer 3 VPN, which is one of the feature of MPBGP. BGP can do n number of things. One of the BGP's feature is MPBGP, means a layer 3 VPN. I can name 2-3: VXLAN, EVPN, VPLS, segment routing. All these MPLS can carry. All this BGP can support. That is why we call MPBGP, multi-protocol. Layer 3 VPN, MPLS layer 3 VPN is not MPBGP, it's one of the MPBGP feature. So we are going to see now how layer 3 VPN we can have between the provider edges so that the inside routers need not to maintain the routes for those external networks. Let me draw a diagram. Provider edge, provider edge. Oh no. Provider only router. Provider only router. Provider only router. You may have many routers. And this is one ISP. We got the customer connected this side. When customer advertises route, in our previous lab that we did, the customer route 1.1.1.1 and 2.2.2.2 was learned on all this routing table. And labels were assigned to those customers' route on every router. So, because of that IBGP split horizon issue, I did not run BGP between this provider edge 1 and provider edge 2. I redistributed. You saw me doing that. And we were having routes of the customer in this P1, P2, P3, P4 route. The 22222 and 1111. You see, not only the PE router learns the customer route, every router in the service provider learns the customer's routes. There may be many customers. And all their internal routes, if a provider starts learning, then they need very big routers, very costly. Not only this router, every router needs to be a big router because they all learn all the routes, they process all the routes. What is the solution? How can we avoid buying big routers? Or how can we avoid learning all the customer's route in these internal routers? How can we make customer comfortable? Customer is not happy when we learn their private networks in our routing table. Customer is not happy to allow us to know the routes to reach their customers inside network. Customers are not comfortable, they don't feel safe because providers router know the routes to come into their company. They don't like it. They're not feeling comfortable. So how can we solve this problem? We are going to form a tunnel between these two using BGP and MPLS.
So is it said VRF?
Yes. So we are going to form a tunnel between the provider edge routers using BGP and MPLS. So far, I have not spoken anything about what Arindra was saying. We are going to form a tunnel between provider edge 1 and provider edge 2 using BGP. The negotiation protocol that makes this tunnel come up is not VRF. It's BGP. That's why I don't want to use the word VRF now. So, using BGP, BGP can form neighbor with a remote router. We all know that. An IBGP neighbor can be a remote router as long as there is a reachability. We have OSPF to provide reachability between the provider edge 1 and provider edge 2. We got OSPF to provide reachability between provider edge 1 and provider edge 2. Using this reachability, we are going to form an IBGP VPN v4 session. So that VPN v4, meaning the tunnel negotiation, is using the IP reachability. It's IPv4 reachability. That's why it's VPN v4. For the tunnel, it is IP address involved. That is going to negotiate IP addresses of this provider edge 1 and provider edge 2, which is a pingable address, is what going to be used between this router in order to form the tunnel. That's why it is MPBGP. That's why it is layer 3 VPN. So the role of BGP is to bring the tunnel up and take the label provided by this provider edge router for this customer network 2.2.2.2. Customer network is learned through advertisement. For this, the provider edge is going to assign a label, let's say 40. These infos will be advertised via this, and this will learn it. Likewise, 1.1.1.1 label number 60 is advertised via this. It is learned here and advertised here. So now this router knows about 1.1.1.1. This router knows about 2.2.2.2. Now, in order to reach this tunnel endpoints, let's say this router's IP address is 3.3.3.3. This router's IP address is 7.7.7.7. In order to reach the other end of the tunnel, and another layer of MPLS is going to be there. Say, for example, when I ping from this router, ping to that 2, packet goes here. Now this packet is going to take first this label 40. That 40 label is coming like this, and PE1 has learned label number 40 for 2.2.2.2, and PE2 has learned label number 60 for 1.1.1.1. So the PE1 router assigns an inner layer of MPLS with the label 40, and outer layer with with a label that you use to reach 777. So if this router is advertised 777 with a label number 17, we'll put that 17. So as the packet moves here, this label will be changing. The label given by this, let's say 23, and then the label given by, and then packet goes here, and the label given by router 4 will be used. So this is what the label used to jump between the routers till it reaches the PE router. We call this layer as transport. Transport layer, and the label is transport label. And this is going to be processed only by the PE2 router. When it reads 40, it understands, oh, he's talking about 2222, so it pushes the packet to CE2 by removing this. So here, two layers of MPLS. One is the service layer, another one is the transport layer. The service layer is to identify the remote tunnel endpoint. Transport layer is to move the packet towards the tunnel endpoint. Two layers of MPLS. Two label. Transport label, service label. Service label is a label given by the remote PE router for the customer network. Transport label is the label given by the provider routers inside the service provider cloud. In our previous example, lab demo, we have seen only a transport label, transporting packet hop by hop. When we enable MPLS, an additional layer of MPLS layer gets added to the packets. That label in that layer is what called as service label. After layer 2, when a packet is received, after layer 2, there will be an MPLS layer which is called as transport layer. And the bottom of a stack bit will be 0 because that's not the last MPLS layer. There is another MPLS layer. So the packet will be switched inside the core by using the transport layer. When the transport layer is popped, when it reaches, from here to here to here, this is going to pop the transport layer completely. It's going to pop this layer and send only this one to the bottom of a stack 1. And when PE2 receives it, it understands this is the last layer of MPLS and 40 is the label I need to look for. It looks for 40 and it understands it's for 2222 and it knows 2222 is in this direction and it pushes the packet in the direction. All right. We understood here that when we have labels and tunnel, there is no need for learning the customer routes on every router in the provider network. It's only the edge router needs to learn. Only the edge router needs to learn. This is a very big advantage. You see, you no need to go for route reflector or configuration or any other full mesh solution here. Anything that PE1 learns from CE1 will be given to PE2 without any problem. And PE2 will also give it to customer edge 2 because customer edge 2 and PE2 is not an IBGP neighbor. So there is no BGP split horizon issue here. No IBGP split horizon issue. There is no need for any full mesh or confederation or route reflector needed. Very big advantage. MPLS with BGP can provide a layer 3 VPN. See, this label concept is also there in SD-WAN, software defined network. There we call it as TLOG, transport locator. Uh, that's not the area now today. We are not going to focus on SD-WAN. So focus here. What I'm coming to say is it's very important. What you are learning is very important. Not only for MPLS, it is also for various other topics, advanced topics. Someone has turned on the mic.
I
Yes.
have a question. So in this case, the MPLS in the transport form is actually the underlay, and the MPLS tunnel is actually the overlay.
Exactly.
Uh,
Exactly.
right. So, okay, right. And then the other thing is, you said the this core need not have to learn customer routes in the core, and that is the advantage of this.
Yeah.
So the transport from P1 to P2 happens only on the basis of the label.
Yes.
So and then it uses the underlying OSPF to actually, like, I mean, because OSPF provides reachability from P1 to P2, that is what it uses.
To
So
identify the remote tunnel
it's
endpoint.
yeah. Okay. And the other thing is, which I do not understand very well, is I see VPN being used uh, very widely for many things. What does it exactly mean? I mean, from the basic definition, it means like, okay, you have a virtual private network wherein you can um, expand your network from one end to another, um, and have some sort of a private network. But why is it called as a VPN? Like MPLS VPN? Why is it called as MPLS VPN? Like
Is it?
what can the customer use? Like how can the customer use this to call it as a VPN? Is it because CE1 can talk to CE2 and using a service provider in the middle, and basically whatever, and that's why this is called as a VPN?
Okay. It is VPN because the customer edge one routes that are learned on this PE router, in this PE router's routing table, is hand over to the remote router PE2. The routes are hand over to remote router PE2. And PE2 provides it to CE2. And CE2 and pings CE1 using the route. The packet comes to PE2 with the original destination. But PE2 encapsulates the packet with an additional layer, which is to identify PE1, not the CE1. Only with that upper layer, encapsulated layer, to identify the PE1, the location of PE1. The inside routers, the blue routers, forward it. The blue routers don't work for the C1 destination or C2 destination. It works only to find how can I reach this PE1 or PE2. If traffic is coming from CE2, P4, P3, P2, P1, they are simply forwarding the packet to a destination called 3333, which is PE1. And they use the label to reach 3333 and move the packet to PE1. And P1 only reads the original destination, which is 1.1.1.1, and delivers the packet here. So only if there is a VPN. What is VPN? An encapsulation. Any VPN, that doesn't matter. It is encapsulation. VPN simply means encapsulation. There is nothing called a tunnel, PVC, plastic pipe, iron pipe. There is nothing like that in network. There is nothing called private VPN, virtual private network. Those are all for our understanding. They have put those terminology. Basically, it is an encapsulation. If the packet is going with a source of 2222, destination 1111, R4, P4, P3, P2, P1 cannot forward. They don't know the route. Fine. What route they know? They know to reach 3333. Okay, fine. Then let us encapsulate 3333 on the top so that P4, P3, P2, P1 will move the packet from the right to the left. After moving, let us read the inner header, which is saying destination is 1111, and deliver the packet there. This is what we simply call it as VPN. Basically, it is encapsulation. Question, please, if it is not clear.
Sir, I have one question.
We'll just finish with Gaurav. Any other question?
Yes. No, it's clear to me now. Yes.
Right. Yes, Arindra.
Sir, that means that tunnel endpoints between P1 and P2, this tunnel endpoints is routed over P1, P2, P3, P4.
Correct.
Am I correct, sir?
According to P1, P2, P3, P4, they think that they are forwarding traffic only between P1 and P2. Actually, the packet is from C2 to C1 and vice versa. But none of this blue router see the original source and destination. They see only one label, which is pointing towards the IP address of the provider edge. So using that label, they understand where they need to go. They need to go to the provider edge, so they move the packet. Any question?
No, normally, sir, in the tunnel concept, we have tunnel source and tunnel destination, right, sir? So I'm assuming from C router, whatever the routes came to the P1, we have a tunnel between P1 and P2. Let's say 3.3.3, that is a P1, and P2 is
7.7.7.7.7. 7.7.7.7 I have written there. Let's use 777 and 333. Yes, go ahead.
So this 333 and 777, these two are routed over P1 and P2, P3, P4, along with the label.
Okay.
Am I correct, sir?
Yeah, so because we are using MPLS, it is only the label, as our Gaurav said, it is only the label that is going to push the packet from P1 to P2. They need not to know the IP address of P2 when the customer packet comes from C1. They need not to know because you already established a tunnel. You have already established a tunnel using BGP. BGP tells to PE1 router, hey PE1, you know where you should deliver this packet? I have to deliver the packet to my IBGP neighbor PE2, who is 777. Okay, Roger, sir. Then what is the label for 777? Let me inject that label. So only that label is got encapsulated. It is not, as you are saying, tunnel source 3333, tunnel destination 7777. It is not tunnel source and tunnel destination. Rather, it is only the tunnel destination's label. Got it?
Yeah. So we'll have more clarity on once we have
No,
lab.
you asked
then
me
the
question
config.
where you are not clear. I'll answer you. Try to ask me question. Put it in a easy way to so that I will understand your question.
No, sir, I'm a little bit having doubt.
Where?
Once this reach to P1, this P1 to P2, how, because my physical path is P1, P2, P3, P4. With that means that tunnel is routed over this path only.
Yes.
So how this P1 and P2, we have a IBGP neighbor. Yes, the way normally the tunnel works, whether it's the GRE, IPsec, or this one. So we have tunnel source and tunnel destination. So tunnel source and destination, it should be routed over somewhere, sir. Then how the packet will flow? Because the routing table will have that route to reach from P1 to P2. And then we have an additional layer, that MPLS. So these things I'm a little bit confused.
What
I don't know
comes
how the
first?
flow is.
What comes first? MPLS comes first or IP comes first?
Routing.
What?
But yeah, in the layer wise, we have MPLS.
Okay, layer wise MPLS. So when a packet is received, router is going to see label or it is going to see layer 3 header?
Label.
Then why you need a tunnel source, tunnel destination? When you already have a label telling, go to that PE, this is the address, this is the label. There is no address, it will say this is the label. Anyway, you are not going to look into routing table, nor the IP header on these blue routers. None of these blue routers are going to look into your layer 3 header even if you have tunnel source, tunnel destination. They are going to only see the label. Then why you need a tunnel source?
So it will look only the label and there will be
Of course no.
destination.
Of course no. That is what MPLS is. We don't want to waste time in looking into layer 3 header, all the fields. That's what I'm telling from the beginning. The advantage of MPLS is you don't look into the layer 3 header.
Yeah.
Then even if you add tunnel source and destination, it is of no use. So it is not added. It is not added. Your packets will be added only with the label of the remote tunnel endpoint. For P1, the remote tunnel endpoint is 7.7.7.7. Now the label of 7.7.7.7 given by P1 router will be added by PE1 router, which is called as transport label. So using the transport label, like yesterday's lab, it will go from here to here to here to here to here. But inner label is label number 40, which is saying it is for this custom. So there is no layer 3 header added. So you compared with GRE, you compared with some other tunneling concepts, so you got an idea. There we had additional layer 3 source and destination. Now where is that here? My question is, why do you want that? You are not in GRE anymore. You are not in IPsec anymore. You are in MPLS. When you have MPLS, why you talk about IP address? It is the label corresponding to the IP address is what you need in order to move the packet hop by hop inside. Ask me question if you have.
Got it, sir.
So can we get rid of MPLS in the middle, like P1, P2, P3, P4, and just have MPLS on P1, P2, and OSPF between these?
What? You need
Even
MPLS
then,
on
would it
every
work?
router.
Like,
No, it won't work.
so would okay wouldn't like, so basically instead of label switching, it will just do routing between the core and then deliver the packet to PE2, after where your MPLS label will be stripped off. So instead of doing just fast label switching in the middle, you just do routing to OSPF. No?
I'm sorry. I'm totally not getting your question. Repeat again, please, with clarity.
So what I'm asking is, like, the reason why we do MPLS is because we want faster switching. We don't want to do a layer 3 lookup and all of that.
Mm-hmm.
And we just want to do MPLS label. Based on the label, we just forward faster.
Correct.
Now your provider edge 1 and provider edge 2 have a tunnel between them, among themselves. So there is a tunnel from one to end.
Mm-hmm.
And then there is OSPF in the middle, from P1 to P2. On all these intermediate routers, there is OSPF.
Yep.
So even without MPLS in the middle, can you still get it to work? Like,
no way. It is not possible. You must have MPLS. Why? You are going to transport between P1 and P2 only based on MPLS. Because this is layer 3 MPLS VPN you are configuring using BGP. It needs only a label as a transport. You don't want source and destination IP address. So you need a label to get encapsulated, not any layer 3 address. So routing is not an option. You cannot have MPLS only on P1 router, P2 router, and no MPLS on P3 and P4. Not possible. Why? When PE2 receives the packet, it should find one layer of MPLS, which means there are two layers of MPLS when it was received in P4. Now packet is coming from this direction. This layer is a VPN layer or service layer, and this layer is a transport layer which is popped off. None of this router were reading this inside layer. Because it is popped off and sent, PE2 alone can read this inside service label, which is pointing towards the customer's route, and it can deliver. So you cannot have some of the core router with MPLS and some without MPLS. You cannot have no MPLS on blue router. That's not at all possible. Every router between, including PE1 and PE2, every router between this PE1 and PE2 must run MPLS. Is it clear?
yes.
All right. So we understood here that labels are distributed over the tunnel And these labels are customer route label, the label that advertised through the tunnel. The labels that are advertised inside the service provider between every hop is only for those networks within the service provider network. Other than PE routers, all the routers are going to only process the label that belong to the service provider network. Only the PE1 and PE2 router is going to process the label that is given for the customer's network, customer's prefix. The label encapsulation happens on PE1 if the packet is going between A to B. B is a customer to router. If packet is going from A to B, PE1 will encapsulate with 2 layers of MPLS, with the top layer the following router like P1, P2, P3, P4 understands that I need to deliver the packet to PE2 and it delivers it. And when PE2 receives, it will have only 1 layer of MPLS and the label in it is the label of the customer's route. So it can deliver to the customer now. By removing the label, it delivers to the customer. So the final decapsulation happens on PE2. The first decapsulation or popping off, that's what decapsulation. Popping happens on P4. Same thing if packet is going from A to B, the transport label will be popped off on P1. The service label which point towards the customer's prefix will be popped off on PE1. So we can clearly see here the labels only involved in moving the packet between PE1 and PE2. No IP address. The Narendram has got a big doubt. How PE1 knows that I need to send the packet to PE2? It is all because of the BGP negotiation that happened. We configured BGP to form VPN with that PE router, remote PE2 router. So any packet comes from customer, PE1 will encapsulate with a label given by PE2 over the tunnel plus the label to reach PE2. So from now on, from this router onwards, there is label sufficient to carry the packet to the other remote end. So there is no need to someone point towards P2's IP address. There are labels sufficient enough to carry the packet to the P2. Right? Fine. Any other question?
No, sir.
All right. So I have explained you the important portion of MPLS layer 3 VPN. But there is also another part to this MPLS layer 3 VPN, which is called as VRF, which allows you to use that single VPN for multiple customers. That's the role of VRF here. VRF is not VPN. VRF is not going to give you VPN. VRF becomes the tunnel opening point when you create VRF. But VPN is actually, the tunnel is actually coming up because of BGP. When you create VRFs, they become part of that mouth, that tunnel's mouth. That's all. They become, they go and sit on the opening of the tunnel. And whatever enters into that opening goes inside the tunnel. Blue, like that. So you can have many customers. All customers' route will be into that same MPBGP tunnel, and it'll go to the other side and it will give it out to remote VRF. I do not want to get into that. It is also another important portion. What you learn today is very important. What you're going to learn in next class, which is pertain to the same MPLS layer 3 VPN, is also very important. Because there is something called route target, route distinguisher. These things always people get confused. I don't want you to have a short class on that and you also remain confused for another 3 days. So we stop here. We are